Hello everyone, I am Preeti from Sri Venkateswara College of Engineering, Department of Computer Science and Engineering, Cyber Security. Today I want to discuss about ADA. In ADA, I want to discuss about Kruskal algorithm. Kruskal algorithm is a well-known algorithm for finding the minimum spanning tree of a graph. It is a greedy algorithm that makes us use the fact that edges of a minimum spanning tree must from a subset of the edges of any other spanning tree. Introduction to Kruskal algorithm. Kruskal algorithm is the concept that is introduced in the graph theory of discrete mathematics. It is used to discover the shortest path between two points is connected weighted graph. This algorithm converts a given graph into forest considering each node as a separate tree. Kruskal algorithm is popular method for finding minimum spanning tree in connected weighted graph. It was developed by Joseph Kruskal in 1956 and widely used in network design. The algorithm focuses on adding edges in order of their weight while avoiding cycles. Minimum spanning tree. Minimum spanning tree is a subset of the edges of connected edge weighted graph that connects all the vertices together without any cycles and within minimum possible total edge. It is a way of finding most economical way of to connect a set vertices. And minimum spanning tree is a graph of subset of its edges that connects all vertices with a minimum possible total edges weight. The tree must include every vertex without any cycles ensuring connectivity. Multiple minimum spanning tree can exist for a given graph if their edges are equal weights. Graph representation. Graph representation is a way of analyzing numerical data. It exhibits a relation between data, ideas, information, and concept in diagram. Kruskal algorithm operates on undirected graphs with weighted edges. The graph can be represented using an edge list, which is a simple and efficient structure. Each edge in the list contains a pair of vertices and the weight of the edges connecting them. Steps in Kruskal algorithm. There are 4 steps in Kruskal algorithm. First step is sort all edges in increasing order of their weights, and step 2 is pick the smallest edges. And step 3 is check if a new edges create a cycle or loop in a spanning tree. Step 4 is if it does not form a cycle, then include that edges in a minimum spanning tree. The algorithm begins by sorting all edges in non-decreasing order of their weights. If then initialize a forest where each vertex is its own tree. The main loop of add edges to the minimum spanning tree while ensuring no cycles are formed. Sorting edges. Edge sorting is a technique used in advantage gambling where a player determines whether face down playing cards is likely to be a low or high at the casino table games by observing, learning, and exploiting suitable unusual difference of the books of the card begins the default. Sorting is a crucial step in Kruskal algorithm to facilitate the selection of the smallest edges. A common sorting algorithm like quicksort or merge sort can be used for efficiency. The time complexity for sorting edges of O of e, log e, where e is the number of edges. Union find data structure. To efficiently manage the check cycles, Kruskal algorithm use the union find or disjoint set union structure. This data structure supports 2 primary operations, union and find. Union find helps in merging trees and determining whether 2 vertices belong to the same tree. Union operation. Union x, y changes the family by replacing 2 sets, the one containing x and the one containing y, by single set that is the union of these 2 sets. The union operation combines 2 disjoint sets into a single set. It is essential for maintaining the forest structure while adding edge of the minimum spanning tree. Union by rank of size can optimize this operation, keeping the trees flatter. Find operation. The find operation returns the set of elements to which given element belongs, whereas the union operation merges two disjoint sets. You need to divide the provided graph G of v, v into the 3 separate sets while building the minimum spanning tree by using Kruskal algorithm. The finding operation determines the root of the set containing a specific elements. Path comparison can be used to flatten the structure, speeding up further queries. Efficient find operation are vital for reducing the overall time complexity of the algorithm. Adding edges to the minimum spanning tree. Minimum spanning tree is a subset of edges of a connected edge weighted graph that connects all the vertices together without any cycles and the minimum possible total edges weight. After sorting the edges, the algorithm iterates through each edge in order. For each edge, it checks whether the two vertices belongs to different sets. If they do, the edges added to the minimum spanning tree and the sets are unioned. Stopping condition. The algorithm continues until the minimum spanning tree contains exactly v of one edges where v is the number of vertices. If the edge would form a cycle, it is skipped ensuring the tree remains acyclic. The process guarantees that the resulting there is a minimal and covers all vertices. Time complexity. The time complexity of Kruskal algorithm is 0 of E log E, where E is the number of edges in the graph. The complexity is become because the algorithm user priority queue with a time complexity of E of O of log E. However, the space complexity of the algorithm is 0 of E, which relatively I. The overall time complexity of Kruskal algorithm is 0 of E, log E due to sorting. The union find operations contribute nearly constant time complexity thanks to optimizations. This efficiency makes Kruskal algorithm suitable for spacecrafts. Applications of Kruskal algorithm. Kruskal algorithm is used in network design such as telecommunications and computer networks. It is also finds application in clustering algorithms and designing efficient transport routes. The algorithm is beneficial in sensors where the graph space is and edges weighted by very significantly. Example of Kruskal algorithm. Consider a graph with a vertices A, B, C, D and weighted edges connecting them. By applying Kruskal algorithm, we can visualize the selection of edges step by step. The final output will be minimum spanning tree connecting all vertices with a minimum weight. Advantages of Kruskal algorithm. The algorithm is straightforward and easy to implement compared to the minimum spanning tree algorithms. It is particularly efficient for space graphs with few edges than vertices. The use of union find encap's performance is in managing the growing tree structure. Limitations of Kruskal algorithm. Kruskal algorithm may not perform well on dense graph due to sorting overhead. It requires additional space for storing edge lists and unified structure. The algorithm might be less intuitive compared to the Prince algorithm for some users. Thank you for watching my video. Your support means a lot to me.